Hello everyone, my name is Chetna Biswas and this is my YouTube channel mathspole. I welcome you all to this YouTube channel where we will talk about mathematics and we will try to understand every concept of mathematics in details so that basics of every one that is troubling you out will be cleared out. Right. Secondly, we will also be trying to solve questions from previous year so that you will learn how to apply the concepts on the questions that is frequently asked. So right today I picked one small topic just to discuss with you all the basic definition of set. So today's topic is set theory where we will be studying about the definition of set and then axiom of regularity, axiom of choice, Russell paradox, well ordering principle and so on. So let's get started without wasting any time now. The first definition is set. I will write down the definition here. By set we mean a well-defined collection of distinct objects. Let me highlight the key points here. The first one will be well-defined and the second one is the distinct property, right? By well-defined we mean that there is no confusion with the definition of a set, right? So all the qualities are not included here. By well-defined we mean that there does not exist any confusion about inclusion or and exclusion of object, right? And this is the symbol of there does not exist. And also I let me tell you few notations about sets. This is belong to. If I cut it straight through it will become does not belong to, and hence I will be using all these symbols in my definitions and in writing part. So let's get back to the definition. I was talking about the well defined property. By well defined property we mean there is no confusion about which element we should include or which we should not include in our set, right? Qualities like best, good will not be considered here because anybody else's opinion will say that A is better and someone else will say B is better. So the property, this property will not imply a unique set, right? So if you ask a person A, write down the set of all best players, he will write A1 is the best. And if you ask B, the answer will be B1 because according to B, he can say another player is the best player. So hence you will not get the equal set, and that is why you cannot consider best, good, great, nice. These all are not well defined properties. So if you ask the definition of well defined, you can consider that is universally accepted, right? And everyone will write the same answer of the question. That property is called well defined. If you ask me one example, I can give you one of set of all natural numbers greater than equal to 2 and less than equal to 5. So everybody will have the same answer 2, 3, 4 and 5. So that is why this property can be considered in well defined because everyone will give the same answer of this question and hence this is well defined. There is no confusion whether 2 should be added in this set or not, or 3 should be added or not, 6 should be added or not. You have to simply check this condition and if it satisfies it will be inside this set, otherwise not. So that is the definition of well defined. Now let's come to the definition of distinct. What do you mean by distinct? That a set cannot have same elements. You cannot write x as a comma a, okay, because here two elements both are same. By distinct we mean it will simply be written as singleton a. How many times it doesn't matter how many times A actually is. If you write it as a set, it will only be considered as a single element. Okay. Now let's move to the next definition up we have is the definition of axiom of regularity. I will be explaining axiom of regularity, but it is depending on the opinion of mathematicians, right? So anybody, if someone believes in axiom of regularity, someone doesn't. So there are two types of mathematicians: one who believes in the axiom of regularity and one who doesn't. Right. So I will be explaining, and according to your point of view, you will decide whether you should believe or you should not believe in axiom of regularity. Axiom of regularity is simply the set, no set can belong to itself. Okay. There are two types of people. I already told you that one who believes, so I will write believer here, and one who does not believe, right? So one who does not believe, one who believes, it says that no set can belong to itself, that if X is a set, it cannot be a member of itself, right? Uh, and if someone doesn't believe in this, according to him, there are two sets. One set is ordinary set, and one is extraordinary set, right? Ordinary set is who which satisfies this property that it doesn't belongs to itself. But for extraordinary set is the property that there exist sets such that X belongs to itself. So it's basically depending on you whether you believe in this axiom or not. I will give you one example of an extraordinary set and one of the ordinary set. Okay, so that you can understand this concept better. Let me erase first this, and I will leave this definition written so that you can relate this to the concept and with the example. So if I write X to be 1, 2, 3. So this is a set which is an example of ordinary set, right? Why so? Because X does not belongs to X, right? X itself is a set, and if it belongs to, it should have been written as this, one element of 1, 2, 3. So this is X. If X belongs to the set was of this form, but we have the set X of this form, and this does not belong to X. So that is why the set is ordinary set, right? Now if I say I have to find one extraordinary set, I will say X be the set of all objects that are not pen, not pen. So in the universe, everything which is not a pen can be in this set. So we can say that this X itself is not a pen, and hence this X belongs to the set, because X is nothing but a collection of all the objects that are not pen. So you can say that this X is also a set which is not a pen, and hence X belongs to X. So this will be an example of axiom of regularity. And the contradiction of axiom of regularity, right? So this is called extraordinary set, which does not belong to the definition of regularity. Okay, so that's it for today, guys. I did not want this video to be that long, so I have made a separate video in a continuation of this part, so you can directly switch to that to know more about set theory. And so yes, thank you guys for watching, and please like, share and subscribe. Thank you very much.